When you hear the phrase, the coldest place in the universe, your mind probably jumps to something far away and mysterious. Maybe the icy plains of Pluto? Maybe some dark corner of the cosmos, where stars don't shine and time feels frozen. Or maybe you think of the void between galaxies, those immense silent expanses that seem totally empty. But here's the thing. None of those places hold the title of the coldest known spot in the universe. Not even close. In fact, the coldest place we've ever discovered was made by humans. And it exists not in some distant galaxy, but in a tiny metal box floating just above Earth's atmosphere. It's a place so cold, so still, that atoms practically stop moving. It's colder than deep space. Colder than the heart of a nebula. Just a fraction of a degree above absolute zero. And what happens at these temperatures isn't just strange, it's mind-bending. But to really appreciate this, we need to go back to basics. Let's ask a simple question. What is cold? Cold isn't a thing, not really. It's the absence of heat, or more specifically, the absence of molecular motion. When you heat something up, the atoms and molecules inside it move faster and faster. When you cool it down, they slow. At absolute zero, which is negative 273.15 degrees Celsius, or 0 Kelvin, all motion at the atomic level comes as close to stopping as the laws of physics allow. It's a theoretical lower limit of temperature. You can't go colder because there's simply no more energy to remove. Now, the universe is a cold place, but it's not absolutely cold. Even the vast voids between galaxies have a temperature. Around 2.7 Kelvin, thanks to something called the cosmic microwave background. That's the leftover radiation from the Big Bang, still echoing through the cosmos nearly 14 billion years later. It's like the universe's afterglow, and it keeps even the darkest corners from reaching absolute zero. So, if deep space only gets down to 2.7 Kelvin, what about the coldest natural object? That title belongs to a strange, haunting structure called the Boomerang Nebula. Located roughly 5,000 light-years away in the constellation Centaurus, the Boomerang Nebula is the dying breath of a star. As this star collapses and throws off its outer layers, it creates a massive cloud of expanding gas. And here's where it gets wild. As that gas rapidly expands, it cools. A lot. In fact, it cools so efficiently that the temperature inside the nebula drops to 1 Kelvin, even colder than the surrounding space. This happens because as the gas expands into a vacuum, it loses energy extremely fast, like a refrigerator cranked up to its most extreme setting. For a long time, this was the coldest known place in the universe. No star, planet, or region of intergalactic space could compete. But then, humans decided to break the rules. In 2018, NASA launched an experiment aboard the International Space Station called the Cold Atom Laboratory, or CAL for short. Inside this box, not much bigger than a mini-fridge, scientists did something incredible. Using a combination of magnetic traps, laser cooling, and vacuum technology, they slowed atoms down so much that their temperature reached just 100 billionths of a degree above absolute zero. That's 0.000000000001 Kelvin. To put that in perspective, this is millions of times colder than interstellar space. Colder than the Boomerang Nebula. Colder than the center of any black hole. Colder than anywhere else in the known universe. But why would anyone want to create something that cold? Because when atoms get this cold, something amazing happens. They stop behaving like individual particles. Instead, they start to overlap and merge in their quantum states. They enter a phase known as a Bose-Einstein Condensate, or BEC. This is a bizarre state of matter where the boundaries between atoms blur. They begin to act as one giant quantum wave, indistinguishable from one another, moving in harmony, almost like a single superatom. Einstein and Indian physicist Satyendra Nath Bose predicted this state of matter back in the 1920s, but it wasn't until 1995 that scientists were able to create a Bose-Einstein condensate in a lab. And even then, it didn't last long. Gravity on Earth pulls the atoms downward, making it hard to observe them in such a fragile, fleeting state. That's where space comes in. On the International Space Station, microgravity allows the cold atoms to float. That means scientists can study these condensates for much longer, without gravity disrupting the experiment. It's like giving quantum physics a slow-motion setting. So what can we actually do with this strange, frozen matter? For one, we can study quantum mechanics at a level never before possible. BoseEinstein condensates help us understand how particles interact at extremely low energies, and that knowledge could unlock advancements in quantum computing, timekeeping, and even gravitational sensing. Some physicists hope that ultra-cold atoms will help us detect the invisible forces shaping the cosmos, like dark matter or dark energy. Others want to use them to simulate the early universe, or even model black hole behavior in a controlled environment. Basically, when we get this cold, nature starts to reveal her deepest secrets. And maybe the most mind-blowing part? This experiment is still running. Right now, as you watch this video, there's a box on the space station circling Earth every 90 minutes, quietly reaching temperatures colder than anything naturally found in the universe. So the next time you think of the coldest place imaginable, don't think of Pluto. Don't think of the void between galaxies. Don't even think of distant nebulas or ancient starlight. Think of a small human-made chamber floating in low Earth orbit, a place where temperatures dip lower than any natural region in the cosmos. A place where the laws of physics start to get blurry and reality itself becomes more wave than particle. The universe is full of extremes, the crushing gravity, blistering heat, cosmic radiation. But when it comes to cold, humanity holds the crown. And in that cold, we may be discovering answers to questions we've been asking for centuries. Thanks for watching. If this blew your mind, go ahead and like the video, subscribe for more journeys through the wildest parts of the universe, and drop a comment below. What other cosmic extremes should we cover next? Until next time, stay curious.